Hello and welcome. In this video, we'll go over how to configure the crawl sub workflow. If you've come from the getting started video, you likely already have the manager set up and configured to use the crawl sub workflow. Our objective with this sub workflow is to give it a URL and to get back all the URLs linked on the page. This process repeats until we have a list of all pages we'll want to get data from. Let's open it up and take a closer look. Like the manager workflow, these purplish notes indicate that we have some settings we can change to refine what data is collected during our crawl. In the example of Ready.gov, we've seen that when these settings are set to empty, we'll be collecting URLs from FEMA, the CDC, Red Cross, and a lot of social media links like Facebook and YouTube. Some of that data is useful, if legal to scrape, of course, but we want to narrow our focus to just links from Ready.gov. The easiest way to go about this is the allowed domains filter. We can set that to Ready.gov or add a comma to support multiple domains like the FEMA.gov domain, for example. For now, though, I'm just going to set Ready.gov, and that will significantly slim down our results and prevent us from crawling websites inappropriately. Those FEMA links will now go to the error sheet so we can track what's still being collected throughout the crawl, but we won't actually visit those sites. In my experience, Ready.gov does not have a lot of subdomains, although what may appear during the course of a crawl is their edit or staging subdomains. We don't want to collect those, we don't have access to them, so they're going to reject our request, and it's also a waste of resources. We can set the allowed subdomain filter to just Ready.gov to prevent this, or set edit.staging.ready.gov, edit.ready.gov, and the block subdomains to ignore these results. And when I say ignore, what I really mean is keep out of our input sheet. Any results that we're filtering out will end up in the error sheet. You can selectively disable that error sheet node and not track that data, but I personally like to know what's being collected, so I'm going to leave it on. NASA is actually a really good example for filtering subdomains because they have a lot of them, which is why I've set it as the example for this filter. With these settings, we'll only get results from the base nasa.gov and science.nasa.gov that ignore all other subdomains, which includes the plus.nasa.gov subdomain, which has a lot of videos, but that won't be useful to us as we're just interested in text data for now. The National Park Service is also a massive website with tons of subsections. We'll look at this example a bit further when scraping, but just to touch on it, we can set the allowed subsections to just fossils to give us a very small collection of interesting data rather than everything the national parks has to offer. Ready.gov is the better example for blocked subsections. They support a lot of different languages, which is great, but it gives us a lot of duplicate data. Plus, I'm only planning on querying our data in English, so all the other languages don't do us much good. This will allow us to exclude those results. Finally, the data type filters prevent anything other than HTML or PDF data from coming into the crawler as input. If anything other than that is collected in a crawl, it will appear in the error sheet. For example, PNGs, JPEG, installation MSIs, etc. You're free to replace this regex with your own if you end up expanding the workflow to accommodate different data types. For example, if your website has CSV or XML data, then you can just add a path in the switch node to accommodate it. Cool, so this is going to give us a much more refined crawl than we would have without the filters. Let's do a test. I have a link already set up in the manual input node for ready.gov/local. I'll go ahead and kick this off. And this isn't typical. The HTTP request node is taking a long time here, and there's a good reason for it, because that's not actually a Ready.gov link. That URL redirects to a FEMA URL. I've included some logic that checks the HTTP request to see if there's a canonical URL set, which is essentially our redirection or final location URL. Since our filters are set to only allow URLs from the Ready.gov domain, this FEMA link will go ahead and get filtered out and added to the error sheet. Let's try a new example. We'll go to Ready.gov and winter weather. Let's do winter ready and copy that off. Add it to our manual node and kick it off. So you can see that one's quite a bit faster. It logs its final URL to the crawler output, then looks for any URLs on the page, whether intact or partial, and rebuilds them into new URLs. It compares with what the system's already collected, then filters out based on our data type and domain filters. Cool, so let's open up the manager sheet and see what we've collected. As you can see, thanks to our filtering, we have a lot of results that have been removed and put into the error sheet. Plus, here are our results from the winter ready sheet. Looks like a bunch of PDF documents. And just to show you, this is where that FEMA URL ended up under the pre-crawl filter in the error sheet. Let's go ahead and prep for a full crawl now. We've got a lot of messy data from these trial runs, so I have a tool to help us clean things up. If you haven't already, import the Clear Sheets tool/workflow. Here you can quickly clear all the data from our sheets. If you want to prevent a particular sheet from being cleared, just go ahead and disable its node. I'll just run the trigger to give us a blank state. Let's head over to the manager workflow now and recreate our initial entry to prepare for a full crawl. With the sheets empty, we'll need to recreate our initial entry. So now the only thing in our manager sheets now is the entry I just made. I'll also reconnect the loop, so we'll just keep processing each item as input as it goes along. We'll send that URL into the crawler, and it'll produce a list of new URLs to crawl while filtering out the stuff we don't want. I'll let this run a bit just so you can see. I can even monitor how things are going just by watching the Google Sheet itself. I'm going to let this run just a little bit more just so I can go into some more detail with you. But let's say that you don't want to run this job anymore. Maybe it pulled something unexpected into the input sheet, or the filters need adjusted. While still in the execution itself, you can press the stop button, or if you've closed out of that window, you can go to executions within the workflow to stop it. Or even from the homepage execution section, you can select the manager workflow to stop it. Here's what it looks like after the manager has finished processing all of the URLs from Ready.gov based on our filters. As you can see, it ran through over 600 URLs. With execution memory enabled, we can actually zoom in and review what happened on each run. This is a feature of all end-to-end workflows, allowing you to review how the data was processed. This is really helpful for troubleshooting and when you're making new workflows, so you can pin and unpin and review data. The only downside to this feature is it uses a lot of memory, so I'll talk more about that in the scrape sub workflow video. Let's go back into our manager sheet and we can see that it processed all the items in input, leaving it completely empty. The error sheet has a lot of information, so we can review if there's any additional URLs that we might have missed that we need to collect and adjust our filters for. And the process sheet shows exactly which items went through the crawler and at what time. So at this point, the manager has done its job. And the actual product of the run is not any of the information on the manager sheets, but rather the crawl output sheet. The crawl output sheet is our finalized list of validated URLs that have made it past any of the filtering in place, and making it the new input data for the next sub workflow in the series, which in this case is the scrape sub workflow. Let me tie this together a bit more. I have another tool called Input Management, which will allow us to take the output from one sub workflow and use it as input in the manager for the next sub workflow. So just for this example, I'm going to go ahead into the set inputs node and set crawl as our sub workflow. So for example, we can start out with the crawl sub workflow or even the sitemap sub workflow, which I'll cover later, to get a big list of URLs. Then use that information as input in the manager to then run the scrape sub workflow, which will go out, collect that data, format it, and then get it ready for the next sub workflow, which is the upsert sub workflow, which then puts that into our vector database, which we can then query later. If that's confusing, don't worry about it. We're going to go through all of these steps together, so you'll see exactly what I mean. If you look a little further down the chain there, it's going to be clearing our manager sheet. It's going to clear the input, the error sheet, and the process data. To me, that data is actually pretty useful. So what I tend to do before actually using the input management tool is archiving. Once again, head into our tools and locate the archive spreadsheet tool. Again, all of these workflows/tools are available on my GitHub. Check out the getting started video for the full process on importing the workflows if you're not already familiar. The archive spreadsheet tool will take our selected sub workflow output and append the manager sheets to it, then place the document in our archives folder, which is really useful for comparing between jobs. I'll go to set inputs and set crawl, and then run the job. Now we can go into our Google Drive and see our archive document for later review. Now I feel much more comfortable about running the input management tool since the manager sheets have been backed up and can be safely cleared now. Running the job now adds the crawl output to the manager's input, and we are almost ready to run the scrape sub-workflow. I'll head back into the manager. And unlike last time, since we already have input from the previous crawl, we don't need to use that sheet above to create the first entry. We do, however, need to set scrape as our new sub workflow. Then open it up and make sure all the connections to our credentials are good. Before I wrap things up for this video on the crawl sub workflow, I want to talk about a new service which accommodates a special use case. You may have noticed this gray box in the middle of the crawl workflow. This is where you can tie another service to assist in getting more information from a web page. Edit ends HTTP request node is great, but it does not execute client-side JavaScript or render dynamically generated content, nor does it reconstruct a page's DOM as a real browser would. For that, we need a service like Browserless. Browserless loads the page in a headless browser, executes its scripts, and then waits for the page to finish rendering. Then it returns the fully rendered content along with the final redirect URL for use in our workflow. Where this is particularly useful in a crawl workflow is when pages contain additional URLs embedded in the scripts. In fact, there's an entire path of the workflow dedicated to this section. Well, I want to present a different example to kind of bring everything home. Head back in our tools and locate the data preview tool. This is likely going to be your first stop when exploring new sites to crawl or scrape. It's really useful in troubleshooting and determining if you need to use a headless browser service. As you can see, we have all the same filters available in the crawl workflow and two distinct branches to observe. Here's my favorite example. Let's go to the National Park Service Age of Dinosaurs page. And as you can see, toward the bottom of the page, there's this cool little table of all the dinosaurs found within the park system and when. If we load this URL into the data preview tool, we can check on the HTTP request node output and see exactly what would be scraped. Taking a minute to watch this run, though, this workflow will check for duplicates and makes that process a bit more visible than it is in the crawl workflow itself. It does go through the same data type and domain filters, and then checks each URL with an HTTP head request. This is useful because if a website has a lot of protections in place, it may flat out deny the HTTP head request, especially without some level of batching, which is configurable in the set inputs node as well. Essentially, though, if you start getting a bunch of 403 requests, then perhaps the rate in which you're scraping these pages needs to be reduced, or you need to look to a third-party service like Browserless for these requests instead. Then at the end, we have a full list of all of the validated URLs. What we're most interested in, though, is what text has been extracted, and that is in the HTTP request node here. We can see there's quite a bit of text on the page, but let's look for something specific. Going back to the Age of Dinosaurs, there's a specimen ID for these finds, and let's see if the request picked it up. No. Okay, instead, let's see if we can pick it up with Browserless. Let's go to browserless.io, and I'll just create an account with Google. Then in just a few steps, we'll get an API key, which is good for 1,000 free requests a month, which to me is pretty generous. I'll copy off our API key, then go back to our data preview tool. Browserless is not a predefined credential type in init, but I've got everything pre-configured, so all we need to do is create the query auth credential, set the name to token, and paste in our API key. And activate the browserless node. Great. Now, if we run this again, we'll get some interesting data. First of all, we're getting a lot more URLs since we're getting our data from the browserless request, and it's finding even more URLs within the scripts themselves. Like before, they'll be tested with the head request, and then we'll be able to run a comparison to see if there are any duplicates or are they truly new URLs. Finally, let's check the output of the browserless node and see if we can find our specimen ID. And there's our table. Pretty cool, huh? I've also included a word count to give a quick comparison between the two outputs. Typically, the browserless output is always a bit bigger than the HTTP request node, but a substantial difference may indicate the presence of dynamically generated content that might have information you want. Alright, hopefully that didn't feel like too much of a diversion, but I wanted to touch on browserless because it's also an option in the scrape sub workflow. Thanks for your time, and I'll see you in the next video to start scraping.